research talk, and then I talk, and then you just take listen. But feel free, if you have any questions, feel free to stop me. Okay, so I will try to explain to you why I jumped into this area, and then why it's related to my expertise, and then we will give you some of the research problems or some of the practical problems on the way. Okay. So as I mentioned, I will give an introduction and motivation, and then I will talk about there's some. If you want to do federated learning system, what are the design principles behind them? So in fact, this is an emerging area. My student just back from the one of the AI conference, LEAPS, right? So he mentioned this is the number 5. Number 5, if you rank all the accepted papers according to the keywords. So this is number 5, just below some graph neural network or whatever. Okay, so I think it's quite emerging. And then I will give you something about, as I mentioned just now, I talk about the vision and the roadmap of our study. But of course, this is just our roadmap. It's just a reference to you. But if you are interested in this area, you may try to explore this or revisit this roadmap. And then we talk about our work, including the tree-based system and also benchmark and so on. And later I will try to summarize this talk. So I think the one actually motivate me to do this area is actually we for a long time we care about performance. We try to improve the performance of system, try to improve the throughput and so on. But we find that actually if you look at data, the other angle we have overlooked is actually the data breach. Okay, so about the data privacy or these issues. From now and then, I think you see this kind of news. And then one thing we have, as academia, we have overlooked is that the cost of this data breach is actually, if you look at the survey, actually this is a survey done a few years ago, and then this average cost of a data breach by industry. So if you look at different industry from public, government sector to different sector like energy and health, I think you can see one message I want to deliver to you here is that if you look at the cost, the breach cost, the cost of the one data breach is quite high. It costs you millions of US dollars, right? So of course this is not the direct cost, not just the direct cost. It also have a lot of implicit costs like reputation or if you have a data breach, you have a high cost of user acquisition in the future, right? Because you have this data breach, and then actually user hesitate to join this company or to join this app or whatever. So this cost is quite high. And then if you look at the other one is, I think here in Singapore and also in other places like China, like EU, like US, people talk about the data privacy regulations. So this is something really becomes more and more, I would say, impactful, because whenever we design a system, design an app, you need to pay attention to the regulations. So of course, those regulations, very popular one is from EU, so-called GDPR, right? So GDPR has a lot of clauses. So to be honest, we have one project also funded by AI Singapore. It's actually on doing data federated learning. And in that project, we actually work with one law faculty from SMU. So we actually very keen to look at how those data privacy regulations impact our research. So you can look at the clauses. One of the clauses, like for example, the right to be forgotten, right? So actually the user can request the company to forget our data, to erase our data. Okay, so this is not, please, this is very important. Because actually a lot of data of our data, personal data, has been collected over the years. So you can imagine just like, for example, if you look at the news from China, in these 2 or 3 days, one of the big news is that they already tried to erase the data from the, it's like something like Trace Together in Singapore. Okay, you think about that. So I think there is some impact on this, right? So of course, besides the rights to be forgotten, there are also some other clauses there. So I won't go through all of them, but just let you know, actually GDPR and other like regulation in Singapore, they do enforce how data privacy is protected, okay? And then because of this and that, we actually cause the problem of so-called data silos or data islands. So we have a lot of these problems. The first one is like, you know, for example, one is the hospitals. Actually, they own a lot of personal data, but actually they are more or less like siloed. They don't share with each other because of regulation, because of a lot of concern just now. So it forms a lot of data islands, okay? Of course, these data islands is like, they can share similar measurement. For example, even for skin, we have different clinics, right? You go to different clinics. So actually the same person data, they now distribute in different clinics. The other one is, of course, we do a lot of activity online, so that's why you can see our data also be distributed in different websites, like including insurance, online banking, and so on. So in fact, those data actually represent, if you look at, if you try to build a user profile, I mean, user profile is the one that represent ourselves in the digital world. You can think about it, the digital twins. But anyway, I don't want to enlarge the topic, but just let you know our data from different aspects are already stored in different websites. And then, ideally, if they work together, then they can give you much better recommendation, right? But as I mentioned just now, they are actually islands now. And the other one, very naturally, our mobile phone is actually, individually, we have our phones. Even for one person now, I suppose you have a number of different devices, right? So actually those, inherently, the data forms an island, okay? So you can see the problem of this is our data, the user's data is actually like chopped in different islands. It's not just, I think it's going to be the trend. It becomes more fragmented in the future. So from that angle, we do see the chance of like, no matter we are doing system, no matter you are doing a mobile app or whatever, you need to pay it. I think this is the number one lesson. If you want to attend my lecture, this is the number one lesson to you is that this is the trend. It's not going to be reversed. I don't see the trend like the data will be centralized somewhere. But it's going to be more fragmented in the future. Just because of just now so many regulations, so many trend of using the data. So this is something, I think this is first slides. I want you to pay attention to your research or to speak, particularly for data here is the federated learning. So, but the problem, yeah, I think the big success of deep learning and machine learning is actually data hungry. So we rely on a lot of high quality labeled data, right? So this you see the paradox here. So then the question is, given these data islands, can we still learn a good model by respecting the data privacy, right? So this is the question in our journey, okay? So, and then 5 years ago, if you turn the clock 5 years ago, when I have the questions, I'm looking for the solution, or because as a researcher, we always look at, okay, we have our hypothesis, our question, and then we look at the literature, right? And then when surprisingly, when I look at the literature, I find at that time, Google just published a paper called Federated Learning. Okay, so then actually, if you look at the definition, is actually basically you try to, if you look at the wiki, okay, so basically it's a machine learning technique that train a model from multiple decentralized data source, and then without exchanging their raw data. Okay, so this is from the wiki. But if you look at more precise or more general definition, is how to enable collaborative model training. Okay, it can be, the output can be one global model, or they can have multiple model, personalized models. Okay, but in anyway, it's basically a collaborative training on models from different parties. It can be, the parties can be organization, can be mobile phone, mobile phone, can be your sensor device or whatever, you know, and under the privacy restrictions. So when I say the privacy restrictions, it can be, okay, some level can be just like without exchanging the raw data. Okay, you're still allowed to exchange like models, like knowledge, even gradients. Okay, whatever. So this is, I think, is one kind of definition. But there are more strict one is like how to avoid like something like more advanced attack, like inference attack, or even higher. Okay, you can define them. So this is what I say. It can be, this definition can be more general. But you see, there's some definition to be, we have to be more, make it more concrete, so that the definition can be more applied to in more realistic scenarios. So let's get back to give you some background about the Google's version of federated learning. So I think I suppose these slides will take some time because I suppose not everyone knows federated learning. So you think about the scenario of Google is that they have Android phone. So they have one application, one app is one function is very useful is to suggest the keywords to you. So suggest some frequently used words to you, right? So when you input, you try to use soft keyboard. If you type, for example, AB, and then they may have other words to suggest to you. So basically, it's a keyboard word suggestion. So you think about in this scenario, of course, they will monitor the user input pattern, right? So, but of course, you don't want Google to know your bank password or your whatever, your personal preference or whatever, right? So this is something we need. The Google try to come up with the algorithm to protect the user privacy, and meanwhile to have a very good model for keyboard word suggestion. So you think about this. Each of us, we have we have a mobile phone. Okay, you have your phone, and the algorithm of this federated called fed average. Okay, so we federated average, and then you can see why we call it average. Okay, so basically for the algorithm looks like this. For a local mobile phone, so each phone you will actually, according to your input pattern, you will train a model. Okay, you train a small model. You can name it whatever model it is, neural net model or some other models. These are local and small models. So I loaded here, right? So basically from your one individual mobile phone, you have a small models. Of course, if you look at the scale of Google, right, then you have millions or even billions of this kind of mobile phone, right? And then so that if each of them you have a small models, then you have so many small models, okay? So, and then those small models will be transmitted to the Google Cloud for averaging. Okay, so basically averaging happen here. So basically all the parameters or weights will be averaged here, and then you come up with a new model, C. So you can see from, and basically the C will transmit it to all the mobile phone here. They will use the same global model here, okay? So from the process, you see, so why this is, you can see, look at this whole process. The first one is that there's no raw data is being transferred. What you can look at the whole process, what data has been transferred is on the models, right? The small models. So compare with you exchange, okay, one way is that you just collect all the data, okay, back to Google Cloud. But of course, that will leak out your password or whatever you want to protect, right? So now the thing is, we only, in the algorithm, the only thing to transfer is the model. Okay, so the small models, and then you will do averaging here. Okay, the first thing, if you look at just without exchanging raw data, it does, right? There's no raw data exchange here. So the other thing is that why this method can be more flexible is that in this small model, you can actually add more protections. For example, you can add some noise there. You can have some differential privacy there, or you can actually make the model like there's some ongoing research on, for example, how to make the model more tolerant for the inference attack, okay, for various kind of attack. So you can actually enhance this model here. So you can see from the whole process, it doesn't exchange any raw data, and because of the model exchange, then it makes you can have more advanced technologies to protect the data. Okay, so this whole process, we'll do more iterations. Just now what I explained is just one iteration, okay? So this is what Google does. I think this is very interesting and also very powerful paradigm, as I mentioned. But the problem is, algorithm is one thing. If you look at the success of machine learning, okay, not just, if you look at as I mentioned just now, the success of machine learning, of course, number one is data. We can have a lot of high quality labeled data already. But the second one is, of course, people talk about GPU, right? Because you have the power to train more advanced model. But I think the third factor here is that we do have very easy to use systems like TensorFlow, like PyTorch. So those actually really lower the bar of being a data scientist. Because nowadays you can just build your neural network very easily. With TensorFlow is still kind of hard to use. I mean, you need to program. But on top of that, there are a lot of like auto ML or whatever, easy to build tools for you to use. Okay, so that you don't really need to explore a lot of tricky parameters. Okay, but the thing is, question here is that if we believe federated learning is one of the very important paradigm for solving the data privacy problems in data silos, then where is the tools to assist this process? Like, do we have PyTorch or TensorFlow for this federated learning? So this is something is like trigger our research on this process for 3 to 4 years ago. So if you look at the whole process, federated systems, okay, so it's not new. So if you look at the history of computing, we have quite a few waves of this kind of research topics on federated systems. The first one I share with you is in database. If you look at this, survey is 1990s. So it's almost like 30 or 40 years ago. We have this wave of research on federated database. So the scenario there is that in that time, so if you back the clock 30 years ago, is we don't have much data. So data is very precious there. So if you look at the library, at that time it's very small. It's not like today you can access a big database. So that's why people try to build database locally, like a database 1, 2, 3, and so on. They belong to different parties, but they want to work together to form a bigger database so that we can serve more meaningful queries. Okay, for example, you want to search a book in the library, they give you an interface, a federated query engine, so that you can search the book in different library. Okay, so this is, you can see why they want to do a federation here is because you want people to look at, because data is not enough, right? So they want to work together to give a better service. So this is like 30 years ago. And something just happened almost like 10 years ago is federated cloud. So I mean everyone now uses cloud. But if you look back the clock like 10 years ago, like in the like this paper is in 2011, right? So round the clock is on 2010. So at that time, cloud just started. So why we have federated cloud is because, number one is because at that time, the cloud provider, they do have pros and cons. Not like today, the cloud provider looks alike. Okay, so at that time maybe someone have a more, have more resources, someone have cheaper resources or whatever. So they actually have complementary with each other. So that's why they want to form a federated cloud. On the other hand, another reason is that at that time also the company now many like the big ones like Amazon and Google and so on, they have data center all around the world, right? But at that time, no. So that's why people try to pick up the different cloud providers to offer some kind of reliability. So that's why they have so-called resource redundancy here. But overall, you see, I give you these two examples to motivate you. To motivate you is that if you want to do federation, there must be some feature, some characteristics behind those parties. Okay? So I think if in summary, you can see there are two things among those systems. There are two motivations for forming a federation. One is a heterogeneity. So the parties, the party involved in the federation, they must have some heterogeneities. They must have something, they are different to each other. Okay? Otherwise, there's no need to collaborate, right? The second one is actually autonomy. So actually, when the parties, they work in the federation, they're autonomous. So they don't really depend on another, okay? So that's why you see the similarity here. Of course, federated learning is a new type of federation systems. It's because we are looking at data privacy, and also it's because of machine learning. Okay, here. You look at the train of publications, like more or less like, this is a federated database. It's more like, I would say it's mature already. So federated cloud is also more or less mature. And federated learning is like, really a lot of papers in the recent years. So after talking about this, so if you want to build a federated learning systems, what are the factors, what are the design principles you need to look at? So we actually survey different, the federated database, and also survey different federated cloud, and also some of the, all the papers on federated learning. And then we come out with these 6 dimensions. Of course, these 6 dimensions actually summarized in this survey paper. And then for detail, you can read the survey paper. But I will briefly talk about these 6 dimensions to you to see whether it makes sense to you. What you want to further, maybe in your start, maybe in your research or maybe in your application, you may, if you want to apply this idea, then we look at these 6 dimensions one by one. Okay, the first one is data partitioning. So if you look at the data islands, okay, just now I show you the data islands, how actually the data is partitioned. So basically how the data is distributed. The first one, for example, if all the features space are the same among different parties, then we call it horizontal. Because if you come with a big table, right? If you look at the big tables, horizontal means how you chop. You actually chop among the rows. So basically, different parties, they own a subset of the rows. Then we call it horizontal. So in practice, horizontal federated learning usually is among the competitors. You think about that. So because they own like the same feature space, it can be like different, like it can be, you think about that, it's like Shopee, Alibaba, Lazada, they actually own more or less the same feature, right? So that's why they are actually more or less like competitors. And vertical is basically they own a subset of the features, but they actually own this almost the aligned users. For example, the example is like insurance, online, banking. They look at different features, but the user set can be the same. Okay, so that's why vertical is in a more realistic way is complementary to each other because they are working on different sectors. And I think more likely is hybrid, okay? So you may have some, it's kind of, in some features you have horizontal, in some other feature you have vertical. So that's why hybrid is more realistic in practice, as what we see in applications. Okay, so I explained the data partition. And then machine learning models, I think this is quite obvious, I don't need to mention. And privacy mechanism. So because at the end of the day, the system need to protect the data privacy. So and then we look at different mechanisms like, so far, there are two major kinds of mechanisms to do that. One is a differential privacy, basically adding noise to the data, adding noise to the models. Okay. The second one is the crypto. So basically, is researchers try to use crypto is like, for example, homomorphic encryption, so that you can actually work on the secret data without leaking a lot of information. And the fourth dimension is the communication architecture. In the communication architecture, this is very interesting. Okay, as I mentioned, I come from the parallel and distributed side. So people talk about, number one is the centralized. Still, a lot of things have a centralized server. As I mentioned just now, even in Google's federal algorithms, you see this, you need to transfer all the small models back to a server, right? So this is a central point. When we do distributed system, we don't like it because you can introduce a single point of failure, right? In terms of attacks, in terms of performance, whatever reason. We don't like a single point of failure, right? But anyway, the good thing is centralized is very simple, okay? Simple design. So that's why a lot of system nowadays is still on centralized. But I think if we go into success, then I believe decentralized is the right way. Okay, so this is something I believe should deserve more research on this. And number 5 is on scale of federation. Scale of federation is basically in terms of number of parties. Okay, so usually we have two categories. One is so-called cross-silo. Cross-silo is basically applied to organizations. So for example, you have a number of industry partners. As I just mentioned, insurance, banks, and so on. They're actually huge, right? By itself is huge. But it's just, I think people collaborate with each other because for example, banks, they may have like customers in different flavor. Maybe they are separate in region. Some banks are in a certain region, some other banks in another region. Maybe they want region and they want to collaborate. Okay, this is cross-site. The other one is cross-device. It's basically applied to sensors, mobile phone, and so on. Okay, so those you can see the number of parties can be very different. Cross-silo is basically like tens, in the scale of tens, dozens, I mean. But in cross-device can be huge, okay, can be huge. If you look at like TikTok, right? So you have billions, okay? And motivation. Okay, lastly, the motivation is very important. So as I mentioned, the success of the federation, I think the motivation is very important. I mean, people, why to join this federation? I think that when we do the research and try to apply it to application, we often face a question. Why I want to join this federation? Why? I mean, as a party, why I want to join this federation? So I think the incentive design is very important. And then regulation, the system has to be certified by a certain regulated government agency, for example. Okay, so look at all these dimensions. We find the existing system actually is far from ideal. So at that time, so we have, in the survey, we have surveyed a few like Google TensorFlow Federated, PyShift, and also Fate is by WeBank. So at that time, I think, okay, by the way, this slide can be out of date because a lot of systems have been ongoing, have been developed, actually being developed. So, but overall, I see even after 1 or 2 years of development, still is quite, according to my 6 dimensions just now, it's still far from ideal. So that's why we do see a lot of interesting directions or so-called problems to solve. So I want to go through them one by one. If you are interested in some of them, you let me know. But I will explain to you a few that I feel is very important and also maybe you'll be interested in. I think the first one is the benchmark. So I think benchmark, why is it so important? It's because you look at computer vision. If you look at computer vision, so they have image lag. So this is something really help the community to do research and benchmark their algorithms. Okay, so I think this is number one. We need a benchmark for federated learning. Okay, and beside that, something I want to highlight to you is also data life cycles. I suppose some of you are in industry. Then learning is just one part of the process, right? You handle the data in multiple steps. It actually have a long life cycles from data creation and storage, and then you query, and then you're learning, and so on and so on. I think the whole process has to be thinking about the privacy there. Okay, so although today I share with you just about learning, but in fact, the whole life cycle is equally important. Okay, so that's why I think there are many things to do. So we do. This is something what we inside my research group. That's what we are doing. So we actually aim to build a practical and also efficient federated learning systems. So we call it Thunder FL. Okay, and as a system researchers, we always look at abstractions. Okay, how we abstract the building blocks. So if you look at this, we can look at from top down. Okay, from top down. The first thing is that this is something I learned in the 4 years journey, okay, of doing research on federated learning. Interface is very important. So we need to provide like scikit-learn, Python, and so on. This interface is very important. I still remember I have a project with my student, open source project, we call it Thunder SVM. Actually, we use GPU to accelerate SVM model for almost 100 times for big data. And initially, we just have C++, Java interface, and the number star is a social, okay. But once we add Python and scikit-learn, we find, wow, the number of users, the number of stars is in the GitHub is going to thousands. So really something, I think in interface, if you do some reflection nowadays, if you're doing machine learning, you probably need to use Python, right? So it becomes very like a de facto standard there. So I think this is number one, we need to take care of this. And one level down is the models. So I think as a system, we need to support different models, like deep neural network and tree models, and so on. And then after that, we should have abstraction about infrastructures. So that's why we look at the party. Different party have a different mechanism. You can see we try to abstract the building blocks so that we can support different federated learning algorithms. And below that, we use GPU and FPGA to accelerate the training. There are two common things are very time consuming here. The first one is the crypto. Actually people use homomorphic equations. So this can be one, slow down the whole training process for over 100 times. Okay, so in this process, the hardware acceleration will help. The second one is actually the training itself. For example, deep learning training by itself is very costly. So that's why the other one we can help here. So this is something we have done so far. So we have more or less finished 1.0 and 2.0 more or less there. But beyond is something we can work together. So we do have, we have a few benchmarks for different purpose. And we also have building blocks for people to build their federated learning systems. And we have factory. Okay, we have done a rather complete tree-based system in federated learning setting. And this is ongoing. We try to do assembly designs. We haven't had good result yet. But efficiency, we do hardware accelerations. So beyond that, we do want to have end-to-end, easy to deployment systems. So this is something we are doing. And recently, people are also using more advanced crypto algorithms or more advanced hardware to do this. I think a lot of interesting things in this area. Okay, what I see here is that in this area is really interesting. Is a multidisciplinary area. I come from this angle. So my background, my expertise is on distributed computing and HPC, high performance computing. So data privacy is really something new to me, and I have learned in the past 4 years. Machine learning, okay, so this is, everyone talk about AI, so I think I suppose we need to do some also. So I think this is some very interesting angle. If you do research or development on this, it's really a cross-disciplinary research area. Okay, so I have another maybe 15 minutes. So I will try to, 15 minutes is really short, but anyway, I will try to give you some short and brief introduction about our work. If you are interested, and then actually we can have another chance to do this. Okay, as I mentioned, we have a tree-based system, and we have a few benchmarks. And then we have more advanced, like how to improve the efficiency of the federated learning system, like we call single shot. Basically, just now Google have multiple iterations, but can we do it like, because multi-iteration, you need a lot of communication, right? So the extreme case is that can we do it in a single shot? That means a single iteration. And in fact, we get some very, very promising results. And we also combine with constructive learning and make it another, so actually publish in CVPR. Okay, so the first one is that why we need a benchmark. Okay, since we just mentioned about 6 dimensions, right? Remember that? We talked about the 6 dimensions of the federated learning systems. So laterally, we look at whether existing evaluations or benchmark actually satisfies those 6 dimensions. So unfortunately, at the paper when we write it, okay, so be aware. So you can see all the papers are in 2020. Okay, I to make a claim here because AI developed very fast. Okay, so at that time, 2 years ago, actually none of the existing benchmark satisfied all the 6 dimensions. So so I take and cross here. Okay, I don't really go to the details, but if you look at this, in fact, that's why motivate us to have both. We call, actually, this is our benchmark. Okay, satisfy all this, we can evaluate all these 6 dimensions. Okay, in terms of benchmark, one thing I find is now still is very difficult for federated learning is that it's still in an early stage. Okay, why I say that is in industry, I think it's just in the recent 1 or 2 years, privacy computing becomes very popular. Okay, very popular. So if you go to AI conference, a lot of industry are talking about this. But the problem is, I find, in order to build a benchmark, we need to understand what are the actual applications in the industry and, or even academia. But we find it very difficult is in the sense that usually the data is very important, so that's why you want to protect them, right? Yeah, like medical data and so on. If given those data, people want to share with you. It's lateral. It's kind of paradox, right? So that's why when we build a benchmark, it's very difficult, especially 2 years ago. But I think we should, I asked my student to revisit again because it really grew very fast. But at least 2 years ago, it's very challenging because people won't share the data to us. And even the learning task, they won't share. So that's the problem. So at that time, how can we come up with some realistic task? So what we do is that, okay, since there are a lot of data sets are actually publicly available, can we actually collect some of those data sets and form some meaningful federated learning task? Okay, so this is the condition. This is something we make the decision is that we want only the public available data. So in fact, we look at thousands of data sets. So manually look at this. Actually, it's a time-consuming process. But we come out with some interesting application. Like, for example, your age prediction. We actually come out with 5 data sets, publicly available. They all work in the same task. Okay? And then, so that's why we consider them as 5 parties. Each data set can be 1 party. And then we do federated learning from those data. And you find, and so on and so on. Okay? So we actually cover, we have horizontal learning. We also have vertical and hybrid learning. So we cover, we have a very good coverage on those dimensions, on those 6 dimensions. So just give you an example. Actually, why it works, okay? So we have collected reviews from IMDb and Amazon. Okay, so those actually, if you do NLP, for example, this is a very popular data set. So, and then the task is to do sentiment analysis to see the movie is good or not, right? The review is good, positive or negative. And then basically, we want to double check. So this one experiment, we want to check whether federation really makes sense or not. So basically is that, if you look at this table here, IMDb, of course, you consider 1 party. If you just use a local, you use a solo data set. Basically, you do a train a model from your local IMDb data, and then you test on IMDb also, right? So this is the accuracy. So similarly, Amazon is, you have do a solo, use training on the local data, test on local data. So this is privacy. This is accuracy. And the other one combined, it means I don't care about the data privacy. I just, combine the IMDb and also combine the Amazon data set. Basically, you have a bigger data set without caring about data privacy. So you find actually all the accuracy improve compared with the solo. Okay, again, compare these 2 numbers. Okay, you see this is 1.7. Actually, it's 1.7 is very good, very big improvement already. It's because it's very hard to improve in 1 or 2%. So this gives you the idea. If you combine the data set, they do improve the privacy. They do improve the accuracy. So that's the motivation of federation. Okay. If you do feather averaging, the algorithm I introduced just now, you see the accuracies here. If you look at these, it's almost like combined. Combined is almost an upper bound, right? Because you just combine them without any privacy concern. But if you look at this, it's actually, there's a gap. So there is more research we need to understand. Okay, so when we see this big gap, we think about this. I asked my student, okay, can you explain this? Why? You can see these two comparison, you look at this, combined is the upper bound. This is the best we can achieve, right? Fat averaging is just a baseline, right? You see, in Amazon dataset, it's almost the same, it's already the best. But for IMDb, it's like you lack a 1.4. It's actually a big gap. So I asked my student, can you explain that? Why, right? Because in research, you always ask why. So in the end, we find it very difficult to explain. Because first of all, the model is very difficult to explain because it's based on LSTM. Secondly, we don't know why actually we don't know. Okay, we don't know why it caused this problem. Why on IMDb is good, there's a big gap. Amazon is perform very well. So based on this question, we think about this. At the end of the day, it's about the data. Since we cannot explain why here, but we take another route, we believe that it's because the data distribution is different. So that's why we started another benchmark, so actually called lung IID. So because in how the data is distributed on different parties, it really matters. So it gives you, for example, just two popular image data set, like Cyber 10 or whatever. IID, you find the accuracy is quite good. If lung IID, you see the accuracy drop significantly. You can see from 70% to less than 50%. So it does matters. Lung IID, so that's why we come up with so how explain is why is it cost shifting because you do averaging, right? So we do have a benchmark to explore different kind of lung IID, including label, because you always have labels in the training data set. So those labels the distribution. Okay, in extreme case, label skills. Label lung IID can be one party only have one label. One party only have the data from one label. Okay, so this is so far all the algorithms cannot solve these challenging problems. Of course, there are other lung IID like feature, like quantity, and so on. Okay, I think if you are interested on those all different kind of lung IIDs, you can actually take a look at our papers. So the other one is factory. So we do build a system called factory, and then due to time, I really don't have time to explore all the boxes, but something I want to highlight to you is that I'll skip the detail in the next few slides, but I want to use a few takeaways. First one, why I want to do trees. Because I work with some industry like financial sector, they do like explainable models. Okay, tree structures is really something that can be explainable. The second one is actually tree model learning. The training itself can be very fast. That can be done in real time. Okay, so we give you that's why we focus on tree models. Okay, I skip these details. Just give you a feeling about the results. Okay, here. Okay, so if you look at just look at figure A. Okay, and TFL is the baseline we compare with. SimFL is our own approach. All in is the combined. Okay, is the combined approach. Just combine all the data together. Solo is just in each party work on their own on data set. So you see the test error here. Okay, the higher the worse. Okay, so you can see all in. This is the line at the bottom. All in is very good, right? Because all in is combined, so no private. So this is ours. The blue is ours. So you can see, in some setting we are good. In other setting, there's still a gap. Okay. So, but in any way, we are much better than solo. So that actually federated learning can improve the accuracy. Okay? So this is tree model. And we also can address the inference attack. So I will skip that. The result also looks similar to what we just now. Okay, one shot I've already explained, so but I don't have time, so sorry. Maybe I just go to a conclusion to conclude this lecture, and then give you some time to ask questions. So I think number one is that I hope you understand in machine learning we care about performance and accuracy, but beyond that, data privacy is also very, very important. And secondly, we have in our work we actually focus on the tree models because we find it's quite useful in many applications like financial sector and also in medical also. Not image data, but in medical you have many other structured data. Okay? And I think this is very interesting journey. So I think combine different expertise like in distributed systems, data privacy, and also machine learning. So I think we have some ongoing work, and like we find in the future we actually focus on put our more effort on vertical learning. In the past we do a lot of horizontal learning, but I think from last year we do see the potential of vertical learning because they are actually the parties are on different sectors. They are more complementary to each other, and also they are more willing to work with each other. So that's why we look at this. And all the benchmark and system are in this GitHub. You can, if you are interested, you can take a look. And yeah, we also, if you have friends or you have colleagues who are interested in working on this, we do have projects we are hiring on this. Okay, I think thanks. I will give you some time to ask questions. Yes, question please.
Yeah, my name is Haiduan. Thank you very much for the talk. From Huawei, actually, I'm very new to this AI. Just curious about this OpenAI GPT chat. Recently, the public see quite advanced. Could you give us some comments on this GPT chat from OpenAI? What are the advanced technologies used in their system? Thank you.
Oh, okay. So I may not be the right person to comment on OpenAI. Okay, so because they are the company, right? So, but I want to just share with you my own personal view on this ChatGPT. So first of all, I think it's quite useful. I mean, it's quite in some Q&A is quite useful, and I think it's kind of how to say, it just surprised me. It's much better than previous chatbot, right? So they're number one. But then something I do reflection is that this is really a huge model. This is a really huge model in the sense that you, first of all, you need to have a lot of data. The second one, you need to have a lot of training hardware power. So I think there's some discussion on social media. It's like how much energy it consumes, how much money it consumes, and so on. Okay, so it definitely is a very costly model. So if we reflect two extremes, one is that if you want to go to a very powerful big models, we do have one trend on this. But on the other hand, maybe we should get the other extreme more. If you care about more energy efficient, small data, then there's another possibility is that you may, based on a collection of models, rather than a big model, you have a collection of smaller models. So actually that is something our project is doing. we try to combine a lot of small models. Okay, so I hope that at the end of the day is that training the power is actually not linear to the model size. Is you want to double the model, you need to pay much more cost and energy consumption and so on. So that's why I believe that in some tasks, I don't know, this is still open problem. Which one is better? But I believe in some scenarios like edge computing and so on, a lot of small models, it does make sense. Okay, so that's why I think there are two ways of doing things. One is big and beautiful, big and hairy, right? The other one is maybe small and beautiful. So I think both sides we can. As a researchers, I think we can explore both sides. As industry, I don't know. It's also maybe beneficial for you on look at both sides. Okay, fine. Yeah.
I'm Chen from Temasek Poly. So quite interesting talk. A few things. One of the things is until now I've not heard about because I'm looking at from your research perspective. You're doing trees, right? I'm coming from the crypto part.
Okay.
Okay. I'm the crypto guy lah. So another thing is we are looking at I'm looking at homomorphic encryption. There's a lot of people are doing that already, but what is the key missing part? Because I'm following Microsoft, some of the research trend. There's a thing called oblivious. Okay, there's an oblivious transfer. I think it's fate. But when it goes into oblivious data structure, because you're doing more data structure. So how do you think about that in terms of machine learning? Because I don't see a lot of work on oblivious data structure at all.
Yeah, that is a very interesting question. I haven't explored that angle yet, but I do see a lot of literatures in oblivious data structures. Yeah, so I'm not an expert on this, but I do feel the bottleneck here is that how you do, because you see the whole training process, like you have multiple parties, they want to train, for example, deep neural network, then you do, in the process, you need to do a lot of sum, aggregation, and so on. So I think there's a need to do how you can actually do the aggregation more efficiently, and also of course, on the condition you don't leak out the information. So there are some, like SMC, secure multi-party computation, and also homomorphic encryption. So those are actually still very costly. It's not scalable, because you look at, just now I mentioned, it can cross-silo. It can be dozens of parties. It's a small number. But you look at cross-device, that definitely millions or even more. So then, how you scale, how to do the scalability is one key issue in whether you do SMC, I mean secure multi-party computation, or homomorphic encryption is about the efficiency, and oblivious data structure is about, I would say it's a kind of mechanism that you can offer some of the randomness or some of secure there. Not just oblivious data structure, there are also something like Intel, what's the name? I forgot. The Intel, they do
TEP and
SGX. They have
but that's that portion, that's TEP. But oblivious transfer is slightly different. It's more on RAM and then at the software level.
Yeah.
So at the so we are looking at this. So
but definitely is an interesting angle to look at. I don't see people combine these two yet.
Right, because at the HE level, a lot of time it's very low level that we are working on this. And then when it goes to the network level, it's very problematic because I'm not even going to full feathered learning itself, but even at machine learning for HE, is a lot of issues at that level because first of all, everyone has their own library. Okay. When you talk about binary people, they have their own library. okay, the French. If you talk about the floating point, the Canadian has their own model. If you talk about integer, of course you have Microsoft and the IBM model. So it's very fragmented at a very low level.
Yes, yes.
Okay.
Agreed.
So you want to have a obvious transfer that combine 3 different libraries together. It's almost next to impossible. Okay.
Okay.
Yeah. So that's one of the big issue that actually at the very low level we have all these problem.
Okay.
You know. So so to make it all the way up to the because if you use multi-party computation, yes, but if you look closely into Intel or AMD or even ARM, there was it has not been stopping the vulnerability at that RAM level. What do you call it? Even SGX.
Yeah, RAM is very very hard.
Yeah, because there was a vulnerability for the past. Even this year, they have just discovered another new vulnerability at the CPU level.
Yeah.
So I feel that if you really want to move into FL, the only way is basically to go on Full HE, because end of the day, if you don't do HE, you will have some leakage somewhere.
Yeah, so I do agree. So it's, on the other hand, we do see you need to, as I mentioned just now, the definition, right? You need to trade off different level of privacy. So basically, you need to define your level of protection. So there's no absolute protection. Right? You can come up with some side channel attack, whatever, you know. So
then if we are not doing Full HE, then why we are doing FL? Because I can just use a traditional method of sanitizing data and process it, you see, and do machine learning.
So I give you one example. So the example is like there may be some in a company they have different branch. They have different branch in different country. They don't by regulation they are not supposed to transfer data among the border, but they can allow to transfer a model. Now it's a gray area. So I see there's some scenario that is you can have different trade-off here.
Okay, thanks.
But of course, if you really want the strict protection, that's what you mentioned. I think it makes sense. Yeah.
Do you want to ask a question?
Yeah, thank you so much for this impressive work, actually. For me, I'm coming from A-Star. I'm from machine learning background. I'm quite new to federated learning. Yeah, but one interesting point you mentioned about benchmarking, actually. I have been working for some time, so it's quite common in machine learning, for example, the unfair evaluation between different methods because ununified, like a lot of pillars that not unified. Like we know that even for these deep models, the random weights can make a difference between. So I think this is a big issue, and I wanted to ask because you mentioned, for example, there are multiple frameworks that are people using, and if someone proposed one paper that's using one framework and compared another work that use different framework, is this fair or not? This is one thing about the fair evaluation or the fair benchmarking between different federated learning methods. And if someone wants to get started in this area, where can he start if he want to? If I have very good idea, I want to develop a model, how can I fairly compare against some of the state-of-the-art methods so that I can be published easily? This is one thing. The second question regarding the academic assumptions versus industrial applications. At many cases also in academia we can assume some assumptions that are unrealistic and people in industry would never do this, so they will not apply what we do. So I'm asking currently how is the gap between academic research assumptions and the applicability of these assumptions in the industry.
Okay.
Thank you so much.
Thanks. So the first one, how to get started, is I think this is I can only give you a general answer. Okay, so I think from our experience that that's why we are trying. You see, we have make our code and also the whole, everything open source. So we hope that, in fact, we hope the community will do more open source so that people can repeat their experiments. I think that is, I do see some papers that we also ask, send email to the author, oh, can you share the code or whatever, right? So I do see some tricky part is that some authors, they don't publish their code, and also in their paper, they don't describe very clearly how they set the parameters. So I think that we should, as a community, not just in machine learning, it's actually in a lot of, as a research community, we should make our experiment repeatable. Okay, so I think that is, with the repeatable experiments, then your life becomes much easier. But beside that, I think there's still some facility we can do, like I think Hugging Face or whatever other repository are doing the right things. I think they're doing the right thing. Like paper with code, right? So they do offer some platform for also to share, right? So I think that is something we do think this is something we need to do. And I'm also quite happy to see some industry, they also share their code or whatever online. I think that is something good. Yeah, so I think I think we cannot change everything, but let's do it from our part. Let's do our part, and then hope the community can pick up. Okay, this is to answer your first question. Did I answer your question?
Yes, yes.
Okay. The second one is actually on just now I mentioned the academia assumption versus industry assumptions. So I think yeah your question is very good. So that the question we always ask ourselves, and also when we meet industry, we also ask them. So there is no golden formula. Unfortunately, there is always a gap because we are coming out different angles. As a researcher in university or even A-star, or some researcher in A-star, we are looking at the basic research. So I'm okay with some assumption that is not helping the, I mean, may not be valid or may not be ready in industry right now. I'm okay with that. But the thing is that we hope the research can see the value in the future, right? So not if you currently not valid, is probably is fine, right? Because for example, you come up with a training method that can train billion of data set. Maybe there's no billion data set now, right? So I think it's okay. You know, you do some simulation or whatever. Because we see this scale, it will enable some new applications. Okay? So I think this is, I call it chicken and egg problems. So if you don't have, I don't know, if you don't have the research on, even without some ambition, some, how to say, crazy idea, right? So I think in some sense, crazy idea, it can be unrealistic. Okay, so I think this is number one. The second one is actually on, as I mentioned, how to bridge the gap. So I think we need to have, event like this, I mean, we need to have trial all means to, thanks AISG and also the Cybersecurity Consortium and so on, to have this events. That's why we talk here just about Huawei and so on, right? So that's why we talk with each other to make, maybe hopefully we can be on the same page. So I think Singapore is doing fine in the past few years in the sense that we have a lot of IT companies, I mean internet companies like Shopee, like ByteDance and so on, right? And also recently have quite some Web3 or whatever comes in. So I think we are getting better, but still I think a lot of effort has to be put there, right? So I hope I answered your questions.
Yes. Thank you so much.